direct and indirect forces. So forces, I defined the word force in the previous lesson. A force is simply a push, pull, or twist and involves an interaction with an object. So interaction means there's got to be something happening between you and the object. So pushing, for example, a box across the table, that involves you physically touching the box. Pulling a fridge door open, you're physically placing your hand on the fridge door, opening it. Twisting could be twisting open a bottle lid. And now there's different types of forces. There's direct and indirect. Another way of saying direct, another word for it in science is contact, and indirect is non-contact. I taught my students this in class. Think back to COVID days, those nasty days. Non-contact means there's no physical touching between people. People need to separate, maintain a distance. And a direct force or a contact force requires physical contact. Physical contact between objects. And the key word here is physical contact. And contact, we've explored contact forces before. Push, pull, twist. These are three contact forces, direct forces, because you're directly interacting with the objects. Could be a fridge, could be a door, a chair, a bottle. Then you have non-contact, and this is the exact opposite. So this requires no physical contact, or no physical contact required, another way to put it. And these forces are very important, non-contact forces. They literally define our very existence every day. The one that comes to mind straight away is gravity. Gravity isn't physically touching us. It's acting at some distance. It's all around us in space, gravity. You also have magnetism. Magnetism occurs between magnetic objects, things like iron, nickel, cobalt. So these are specific metals. We actually have iron in our blood, believe it or not. Iron's a metal. You also have the electrostatic force. Electrostatic. What on earth does that mean? Well, electro, think of electric. Static means not moving. Okay, if someone is static, something is static, it's not moving. So put those two words together and you get charge that's not moving. So you get electric, so charge that's not moving. Think of walking on carpet. So here's a person who's walking on carpet and they go and touch a doorknob and they get zapped. Okay, that sensation, that's due to what's called electrostatic forces happening. When you walk, you're moving charges. So charges are things that have like a plus or a minus sign with them. So you're moving charges from the carpet in this case to your body. Your body traps those charges on the surface of your body. And when you touch that doorknob, the charges move from your body to the doorknob and you feel a zap, a little zap. That's electrostatic. That's an example of an electrostatic force. Static because the charges aren't physically moving. They're basically going from the carpet to your shoe and staying on your body. And when you touch the doorknob, the charge goes to the doorknob and you feel it there. So the three main non-contact forces: gravity, magnetism, and electrostatic force. And these all act at a distance. In other words, they don't act with physical contact, they act from far. Gravity, so think of a room. Think of this room here, this rectangle. At every point in the room, there are arrows going downwards because gravity acts downwards. It pulls everything downwards. So it's acting at a distance. That's gravity. You can picture it as like arrows everywhere in space. They have to be pointing down because that's what Earth's gravity does. It pulls us down towards the surface. Magnetism, I want you to think of bar magnets or fridge magnets. So these are bar magnets. They've got a north and south pole. These will be explored, these types of forces, explored a lot more later on in different lessons. But for now, I'm just going to briefly explain what they are. If you have a north and a south pole, they attract. They come together. Okay? And that's because magnets don't require physical contact. They work at a distance. So these are your contact and non-contact forces. With contact forces, so aside from push, pull, and twist, you've also got friction and tension. These are two common ones in everyday life, friction and tension. Friction, if you take your two hands, rub them together, you feel that they'll warm up, and when you take them apart, you find that there's sort of like black stuff on your hands, black rubbery stuff. That's actually dead skin cells, and that's the result of friction. So friction is a contact force, and it requires physical contact between two surfaces. Like rubbing your hands, two hands, right? When you're walking every single day, when you get up and walk, you can try it now if you want, your shoes are making contact with the ground. They're the two surfaces that are in contact, your shoes, the bottom of your shoes and the ground. Tension, that's a force that comes from pulling things like strings. So pulling force, I'll keep these definitions short. Pulling force from things like strings, things that have elasticity, basically strings, ropes, and rubber bands. Okay, and these are things I'm sure you're familiar with. Tension, it's a pulling force that comes from these three things. And things, even things like springs, if you have slinkies as well, but these are the main things. So to summarize contact, you've got things called direct and indirect forces. Direct is another way of saying contact, and indirect is another way of saying non-contact. Contact forces, you need physical contact. That's what the word contact means. You need physical interaction. Non-contact, you don't require any physical contact. Push, pull, and twist, these are contact forces. Non-contact include gravity, magnetism, and electrostatic forces. And they work at a distance. And you also have friction and tension as contact forces.